Thanks to HP for allowing us to present a talk here. My name is Alex. I work for Midokura. Who in this room ever heard of the name Midokura of the company before? Okay, that's good enough. Both of you have already worked with Docker and have set up networks with Docker and host-based networking. Okay, not too many. We're in Bristol today. I have given this talk in Dublin at an OpenStack day in Ireland. And this is I think it's the third version, the fourth or the third version of the talk. And usually we start by explaining what we do not want to talk about. So there's a lot of things in the Docker ecosystem that deal with networking, orchestration. So there's a lot of things you can choose from. And we are here today in an OpenStack crowd. So all of you know what OpenStack is and how Neutron works and what you can do with OpenStack networking. So today we want to talk about how to make OpenStack networking work for Docker, so that when you have experience with OpenStack and Neutron, when you're using Neutron to virtualize your networks, that you will be able to look at Kuryr and say, this sounds interesting, this is what I could use for bringing OpenStack Neutron networking to my Docker environments. So I think everybody in here knows what Neutron networks are, how you can use the different plugins. For example, there are solutions from Juniper, from Nuage, from Cisco. There's the default implementation of OpenvSwitch. There's a new software called OVN. Who in this room has already worked with OVN? Okay. So, and basically the concepts of Neutron networks, subnets, routers, firewalls, the Neutron API pretty much makes it easy for us to use different vendors and different network virtualization products and work with the same expressions and with the same terms. In Docker, it's pretty much the same, other than that they're using different concepts. So if you're coming from a networking background and you have worked with Neutron a lot, then Docker networking, you have to learn a lot of new terms, but in the end it's the same thing. Apart from that, there is a lot of stuff that doesn't make it easy for you to use networking with Docker. So they have spent a whole lot of time reinventing network abstractions. And we're also talking about something that's not quite mature and not quite stable. There's a lot of change happening, and the Docker community is actively working on networking, and that's why we can expect a lot of changes in the future, how Docker wants to work with subnets, routers, and for example, what we in OpenStack have, security groups. All of these things are still evolving in Docker. So for this reason, because Docker networking is still growing and it's still changing, it makes a lot of sense to start a project that allows for people that want to use Docker containers to have a small software that runs on your Docker hosts and makes it possible for your Docker containers to use the networks and the routers you already have defined in Neutron. And this is basically what Kuryr is about. It's on the hypervisor on the Docker hosts. Kuryr is only a small Python program, and on the API side, it's basically a Libnetwork driver in Docker that translates the calls for creating Docker networks to Neutron and when you create Docker containers with the network driver Kuryr, then you will automatically get access to the IPAM and to the networks defined in Neutron. Does that make sense? I like the heat wave coming from the from the screens. So the Kuryr project has been created by several large companies. So it's not only Midokura developers. There's people from IBM, Huawei, Cisco, VMware. So we basically have a lot of people who are already active in the OpenStack, in the ecosystem of OpenStack, and we're actually already having products in the market. And these people are trying to add content to Kuryr, and they are trying to provide code for Kuryr because it makes it easier for the users of these companies to use hypervisors with classic VMs, and the growing demand for container workloads. So as I already said, the reason why using Kuryr makes sense is that Neutron is fairly stable. So there's a lot of things you can do today in Neutron, and a lot of people are satisfied with the way it works in production. So you can have load balancers, you can have firewalls, you can have security groups. For example, our company is using BGP to have the MidoNet gateways talk to physical routers. So all of these things that come from the network virtualization solutions can be used automatically in Docker networking. So the only thing you need is the Kuryr Libnetwork driver on the Docker host, and you need to start the little Kuryr daemon that runs on the Docker host, and everything else is automatic. And they're already working on packaging to make it easier for you to install and run these things. The reason why the Kuryr project was created was the developers wanted to have a common place for doing the translation of the different models. So to do the translation between what Docker thinks is a vPort and what Neutron thinks is a vPort, and what Docker thinks is a subnet, and what Neutron understands as the word subnet. And for every vendor that's getting involved in the Kuryr project, the only thing that the vendor needs to add is a small binding script. The binding scripts are really simple. Example, is there someone from Plumgrid in here? No, good. So this is the example for the Plumgrid solution. So this script gets called by Kuryr when the container comes up, and it's basically the data path. We are binding the data path of the container. The interface of the container we need to bind it to the data path of the network solution. And if I now show you the solution in MidoNet, you will notice that it's really, really similar. So the MidoNet solution is not really different. The only thing we have is this called control. This is basically a tool to do the data path binding on the server, and the Plumgrid solution, it's called IFC control. So it's basically little shell scripts that are used by the Kuryr daemon to call out into the solutions of the different vendors. Yes, please.
So those run on the Docker host?
Sorry?
They run on the Docker host, those?
Yes, the Kuryr daemon executes these scripts on the host where the Docker containers come up. That's right, sir. And for this to work, of course, in the case of MidoNet, you need to run the MidoNet agent, and in the case of Plumgrid, you need to run the parts of Plumgrid that do the control plane and the data path on the server. This is something you have to do. So Kuryr will not do the whole networking. It will only it will only accept the API calls and set up the data path. So far, we have been able to test all of these things. So we had firewall as a service, VPN, VPC peering. We had all of these things working for Docker containers. And all of this was coming out of Neutron. So you define a security group in Neutron. You create a pod, and then you basically can benefit from all. So if anything new gets developed in Neutron, for example, if you have something new coming up in Neutron, then Kuryr is so independent that there is a high chance that it would just work, that you don't need to change anything in Neutron or in Kuryr to put the same feature into your Docker networking for your hosts. Okay. So as I said, the way it works is basically use a remote driver in Libnetwork that translates all the calls you're doing when you're using Docker Network, translates these calls to the Neutron API. So far, we are supporting Dragonflow, MidoNet, OVS, and in theory, every Neutron plugin that's working with Neutron and is providing a binding script can work with Kuryr. There's nothing that prevents any solution from working.
And yes. There are no changes to the Neutron API?
Yes, sir. No changes to the Neutron API. That's correct, sir. So as you see, it's fairly simple. You just say Docker network create, a driver is Kuryr, IPAM driver is also Kuryr, and that will basically create a container on this network. And at the same time, when you then look at Neutron, we're using some crafted IDs to identify the network again. And we also store these IDs in the Neutron text. So in the Neutron text, this has several reasons. For example, we want to prevent people in Neutron deleting these networks because they don't know that they're used by Docker. So what we should avoid is that administrators say, oh, I don't know these networks, and I have no VMs with Neutron pods on these networks, so I can delete them. But if you have a lot of Docker hosts with Docker containers still running on these networks, then it should be there should be at least a warning, or it should be easy for you to find out that these networks are used by Kuryr. And this is something we are working on at the moment. So the life cycle on both sides, because obviously, sorry, go ahead.
So the network that was created in Docker.
Yes, sir.
You put the Docker network create to call the
Yes, sir. That's correct. So the Docker network create command was run on a Docker host, and then Kuryr takes it. It's a small Python script, and then it looks at the command and says, okay, what do I need to do in Neutron to make this happen? And then it just calls Neutron API.
So that script has also got the keystone credentials and doing the rest of
Yes, sir. That's correct. Yes. So and then you can also have VMs and containers live in the same networks. So there's no reason why you should not have VMs, for example, with applications like enterprise applications in VMs, and then you can have Docker containers, for example, with highly scalable web applications or some web framework that you want to run in containers.
You're using the OVS driver on both sides.
Yeah.
You create a Neutron network that spans the Docker and
Right. So when you use Neutron, and Kuryr is configured with a tenant, so you basically say, okay, in this tenant, all the networks are visible in the Kuryr network driver in Docker. That's how it works at the moment.
so all the Docker share a single tenant.
Yes. At the moment, it works like this, but in the future, you will also have tenant isolation that you can say, these Docker hosts for this tenant. Okay. There's the example. So it's basically a small tag that says Kuryr network existing, and then the logic is that we We do not want to delete the Neutron network when Docker deletes the network when there are still VMs on it. And we do not want to delete the network from Docker and Neutron when Docker still has containers on it. Because otherwise, you will always run into split brain situations. Of course, Kuryr itself initially was created for Docker only. So it was possible to launch Docker containers straight, standalone. But obviously, the people want to have some kind of orchestration, so they want to be able to use things like Kubernetes and Swarm with Kuryr and Docker and OpenStack. So what happens is that on every compute node where you have the Swarm agent, you also have the Kuryr service waiting for Swarm to create containers, and then we also make sure that the networking for these containers also works together with OpenStack. And same way with Kubernetes. What's interesting about Kubernetes is that in Kubernetes we can actually make use of the load balancing as a service from OpenStack Neutron. Because when you call something in Kubernetes, there's the concept of a service, which is essentially an endpoint. It's a publicly reachable IP and port that has multiple containers sitting behind it as the backends. And what Kuryr does is Kuryr maps the networking of the Kubernetes service and maps it to a Neutron load balancer construct. And it does all of this automatically. So if your network virtualization solution, for example, Plumgrid or MidoNet or OVS, supports using Neutron load balancers, you can basically have your users create Kubernetes services in Kubernetes, and the way it will be implemented will be with Neutron networking and load balancing as a service. And at the same time, your VMs and your users outside of the cloud can also use these load balancers. And in the end, it's all HA proxies somewhere. Good. So this is a technical slide that explains how the different components, this is an example with the MidoNet agent installed. So MidoNet agent is using the OVS data path to run the data plane on the compute nodes. And Kuryr basically talks to the MidoNet API that's sitting in the MidoNet cluster, and at the same time it talks to the Neutron API. And this is a custom solution that we built for our customers to use Kubernetes with MidoNet and OpenStack, but normally Kuryr should be used independently. So this is just an example to show you how complicated things can become when you build a whole solution out of this. Everybody finished reading? It's my favorite slide. Yeah. I didn't invent the names. Raven, Kuryr, all these names. They're all from a friend of mine, developer. So the next thing when you think about things like OpenStack and Kuryr and Docker and Kubernetes is this really necessary? So why did you guys try to build something? Why don't you just use why don't you just use for example Flannel in VMs, so overlay on overlay? So a lot of people say, I don't care that my packets are double encapsulated. So if you talk to the Docker community and if you talk to the developers, then they say, well, if I'm running on cloud, then if I'm running on Amazon, for example, I will always have double encapsulation because the virtualized networking I get on Amazon and on Google Compute, it's also not physical, it's also not real. It's only some kind of encapsulation, and on top of that, I run my Weave or Flannel networking, of course. But from our point of view, for certain applications, if you run, for example, microservices with very small messages, then 50 bytes is actually a lot of traffic. If your payload for the application is, for example, only like 10 or 20 bytes, then double encapsulation will steal a lot of bandwidth from your applications, because the header, the IP header, will be so large because of the, for example, VXLAN and VXLAN. If your application, if the pattern of the application is so that it generates a lot of small messages, then it really makes sense to think about using something like Kuryr to get rid of the double encapsulation. Because in the case of running Docker containers and VMs, what we have done is we have used VLANs to identify the different networks in the VM that go to the Docker container. And these VLANs are basically managed by a Kuryr component running in the VM, and that basically connects the ports of the Docker containers to different VLANs on the interface. And then on the outside of the VM, these VLANs are then used to by the MidoNet agent on the outer side to identify the container and the networks inside this VM. And VLANs are much more lightweight than adding an additional VXLAN header, for example. And we're still waiting for the customer that tells us, I have a VM with more than 4,000 Docker containers and networks, but then we can still install an agent inside this VM. So we can still say, okay, this VM is so large that it actually makes sense not to run a small Kuryr tagging layer in there, but also run a full MidoNet agent in there to do the virtual edge then inside this VM. Does that make sense what I'm saying? Okay, good. Good. As I said, the whole point is to give administrators and the operators of an OpenStack cloud to make it possible for their users to start using Kubernetes and Docker and Swarm without having to read a lot of hacker news articles, without having to be part of the hype cycle around the latest invention coming out of Silicon Valley. What we basically try to do is we try to use something that works, which is Neutron API, and use small daemons, small Python-based daemons on the machines to provide the Neutron networking for these new services. For us, they're just applications. As long as we can have a data path somewhere with a vPort that we can plug, our solution doesn't care what's behind it. So it can be a fridge or an electric razor. We don't care as long as we can put a data path on it. And that's why Kuryr makes it easy for companies like Midokura, because we get a lot of customers asking, we have OpenStack now, we have VMs now, what can we do with containers? And of course, then this makes it easier for us to sell our software to these customers. At the moment, we support Debian-based, which is Ubuntu, and RDO, which is CentOS and Red Hat. And also there's an integration collar where we are trying to get involved. For the new release, I think Kubernetes integration should be done. Nested containers and Magnum integration, still working on it. DNS integration, port forwarding, this is interesting. Packaging and deployment masters is also on the roadmap. And then what's also on the roadmap for Kuryr is the plan of the developers is not only to do networking, but also to try to map storage storage concepts from Neutron to the Docker world. Yeah, sounds strange. So everybody who has a lot of free time, please join this project. It's still a small crowd, so there's like less than 10 developers, mostly from companies. So if you're interested in contributing, and if you want to work in a small project where there are still people moving in a direction that you can influence. And if that's something you're interested in, please go to the IRC chat room and please talk to the developers. They're very friendly, very nice guys. And Kuryr is still a young project, but it's got, from what I know, it's got a great future. Thanks. Now we can do questions. Yes, please.
So this looks like a great way of integrating virtual machine networking from an OpenStack perspective with container networking,
Right.
unifying them into a single model.
Mm-hmm.
So excuse my ignorance, but what other ways might you do that today? Or is this the only way of doing it?
Well, most of the time what people are doing is they're using the existing Docker and Kubernetes networking, and they're just running their Docker infrastructure on top of OpenStack VMs. It's typically what people are doing, what the first steps are. If the application is good enough that you do not feel the overhead, for example, of the double encapsulation, then this is actually a good thing to do, because OpenStack VMs can be scaled very fast, very good. So you already have OpenStack API, and then you can basically build your Kubernetes cluster on top of OpenStack VMs. It's typically not a big problem, but as soon as you start having a lot of applications with a lot of traffic, you will definitely notice the double encapsulation.
But that, aside from performance issues, that doesn't let you make virtual machines and containers effectively peers on the
Right, that's correct. That's correct. So from a user standpoint, from a usage, from usability, it's also two different worlds, because you have your VMs and then you have your Docker and Kubernetes clusters in there, and then you still need to do some plumbing. And usually, what you do is you use the host networking. So you build a lot of layer 2 connections so that the containers can participate in the virtualized layer 2 networks of these VMs. But of course, this is all difficult, because then when you want to do proper routing, proper load balancing, you will always hit some barriers like you're nutting out of your layer 2, and you get a floating IP that you're nutted, so you cannot identify the container anymore, and all of these things. And with Docker and Kuryr, for example, you can put floating IPs on there, and basically you can make container ports first-class citizens of the whole Neutron networking system.
Excellent.
Yeah. And do we have someone from Cumulus in here? And I know they are outside. So what's also possible is, what's not in the slides, is the Cumulus guys are very good at having their VTAP servers integrate with physical hardware. And for example, MidoNet supports talking to VTAP switches and doing layer 2 gateway using Cumulus VTAP switches. And then when you use Docker and Kuryr, these Docker containers, for example, if you have a large Oracle database cluster or an SAP installation on physical gear, and you have a Cumulus switch that creates a layer 2 connection to these servers, then all the Docker containers can access these layer 2 hardware gateway connections, because it's the network virtualization software itself will do all the magic behind the scenes, and the containers, they will just see the networking, the virtualized networking, and you can do everything that you can do with Contrail and Nuage and these other solutions that where you have all this connectivity, and Kuryr only makes it possible for your containers to see this. Great. All right. Thank you for listening. Okay.